Friends, very good morning to everyone. Today's subject of synthesis is Bernthsen Acridine synthesis. Bernthsen Acridine synthesis. Acridine is an anthracene molecule in which the carbon is replaced by nitrogen. Anthracene is a linearly fused 3-benzene ring system. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And at the 10th position carbon, if I replace by nitrogen, I get acridine. Acridine is an heterocyclic molecule. Acridine can be synthesized by treating a diaryl amine with a carboxylic acid or an acid anhydride in the presence of zinc chloride as a catalyst at 200 to 270 degrees centigrade for 24 hours to give rise to 9 substituted acridine. The approach for the synthesis of acridine is like this. I cut the molecule over here, and if I remove this RC, this part, what I have is diaryl amine. Diphenylamine I'll take as starting material, and I treat with a 2 carbon donor. I take RCOOH. R is one carbon, carbonyl is another carbon, a 2 carbon donor. Here, in the presence of the acid, the pi electrons moves onto the carbon due to the electromeric effect, and I will get electron rich center over here, a carbene ion. The carbonyl carbon is electron deficient center, and this is electron rich center, and as unlike poles attract each other, the electrons, excess electrons over here attacks on the carbonyl carbon. And as I am using zinc chloride, a Lewis acid catalyst, it helps in making OH leave. Dehydration, the OH minus and H plus combine together to lose as water molecule, and I am heating it strongly, it loses water molecule, and I will get corresponding acyl group attached to the phenyl. Again, the pi electrons moves on to the next carbon, creating a carbene ion, and there is the carbonyl carbon. The carbonyl carbon is electron deficient center due to the presence of this electronegative oxygen. Unlike poles attract each other, this carbene ion electrons attacks on the carbonyl carbon, and the pi electrons moves onto the oxygen to maintain the valency of the carbon, and hence cyclization has taken place. As these electrons have moved over here, this has become the positive center. The carbon hydrogen breaks. The electrons are utilized to satisfy the positive center, and again the nitrogen hydrogen bond breaks. These electrons moves onto this carbon, double bond is formed. This pi electrons moves onto the next carbon as it has to maintain its tetravalency, and OH gets kicked off. As this carbon has to maintain its tetravalence, it kicks off OH. This OH minus and H plus combine together to lose as water molecule, and these electrons moves towards the positive center to satisfy the positivity, and this gives us H plus, and I get corresponding cyclized derivative. That is 9 substituted acridine. Acridine is a heterocyclic molecule and there are n number of heterocyclic compounds which have having medicinal value. This acridine containing drug molecule synthesis will be the subject of discussion for the next presentations. Acridine, instead of using zinc chloride as catalyst, we can use polyphosphoric acid. When I use polyphosphoric acid, I can carry out the reaction at ambient temperatures below 100 degrees centigrade. Here, the harsh reaction conditions what I use 200 to 270 degrees centigrade can be avoided. However, when I use polyphosphoric acid, though I can carry out the reaction at lower temperatures, but it decreases the yield. Recently, the instead of using either polyphosphoric acid or zinc chloride, one of the person used paratoluene sulfonic acid, an efficient dehydrating agent. Instead of heating strongly by traditional method, he used microwave heating. That's why the reaction occurred within few minutes and the polyphosphoric acid harsh reagent and the harsh temperature reaction conditions have been avoided and the same acridine synthesis has been achieved. This is how we can develop a new methods for the synthesis of the known molecules, which are more benign, environmentally benign methods, where we cut short the energy usage and we use a better reagents which are more economical and also environmental friendly, and it gives to the green chemical approach of synthesis. Let us look into the other molecules in the coming class. Till then, have a nice day. Thank you.